Hey, 8th grade, it's Mrs. Cartwright jumping into your PLTW class today. I am here to talk you through how we're going to find the angle of impact, which is going to use some major math here. When you have finished your step 2, where you're finding your area of convergence by taking all your strings and then bringing them to where they all connect, and we find that area of convergence, what we end up figuring out is that our droplet's path creates a right triangle. And so that right triangle, in the way that that droplet splatters, gives us an angle of impact. Now, what some of you learned with Dr. LaFollette and what the rest of you are going to get just a real quick flyover, if you will. With right triangles comes a new type of math that we call trigonometry. And so we have 3 basic trig functions. We have sine, cosine, and tangent. Sine you have seen probably on your calculator. Some of you have seen in some of your questions on MAP. We shorten them down to SIN, COS, and TAN. Now these, if given a side length and an angle, help us find a missing side. We're not missing a side here. We're not going to be missing a side. What we need to do is find a missing angle. So we're going to have both sides and we need to find that angle. And so in order to do that, we're going to do what is called the inverse trig function, which you'll see it as 2 things: arc sine or arc cosine, etc. Arc tangent. But in the calculator, or just for quick reference, that's our sine to the -1. Oops, I almost put sine again. Cosine to the -1 and tangent to the -1. But we don't read that as sine to the -1. We read it as inverse sine, cosine, inverse cosine, inverse tangent. These functions help us find a missing angle. Okay, so that's just, again, flyover of trig. What are we going to be using? So you finished your step 2, you found your area of convergence. So now we're going to determine the angle of impact. And so they use what is called law of tangents to calculate the height from which the blood fell, or the point of origin of the blood. And so this is our formula right here. Okay, notice they used arc sine, but then they also used sine to the -1, or that inverse sine. All we need to do is use inverse sine, and then we're going to take the width of our blood droplet divided by the length of our blood droplet. So if we use this blood droplet down here, the width is my small distance, and the length is that long distance, or the direction that it's going. And we already talked about that directional splatter. So we're going to take our width divided by our length, and we're going to find the inverse sine of it. And that's all that we do, and it really is going to be fairly simple. What you do need to know is, well, how do I use the calculator? Because you're going to need the calculator for this. So if you go to my Canvas page, on my Canvas page, as you should know, and I've talked about it with you, there's that calculator that Desmos Scientific Calculator. And so if you click on the little calculator button on my main page, it brings you to this. When we're going to figure this out, we're going to move over to function, away from the main and over to function. Notice that we have our inverse sine, inverse cosine, inverse tangent, right? That's how I'm going to get my inverse sine into the calculator. So pulling back up our PowerPoint real quick, we're going to actually go do a problem. So here's an example. We have the formula is still here for us. We have a width of 1.5 centimeters and a length of 3.0. If it helps, write that out for yourself, right? W equals 1.5 and length equals 3.0. So what we're going to type into the calculator is that inverse sine, and then we're going to do 1.5 divided by 3. or 3.0. And that's going to give us our answer. So going back, I've got to do some special work here. All right, so going back to this calculator, we had, now once I put in my inverse sine, I've got to go back to main to get my numbers. And then we're going to type 1.5 divided by 3. We're going to close our parentheses. Oh, it didn't like that I closed it there. No, give me back. All right, let's close it here. Okay, and so what that gives us is the inverse sine of 1.5 divided by 3 is 30 degrees. And so when we go back here, our impact, our angle of impact is a 30-degree angle. And so from there, you can now figure out from your blood splatters which direction that shot was from. So I hope that helps. If you have your own calculator, scientific calculator, and you would like me to show you how to use inverse functions on your calculator during math class, you're welcome to ask me, and I'd be happy to show you on your own handheld calculator. Until then, see you next time.